The content on Explainevo is created for educational and informational purposes. While we strive for accuracy, we cannot guarantee completeness or timeliness. Please conduct your own research and consult a qualified professional before making financial, legal, or business decisions.
You type a prompt, you hit enter, and the answer appears. This speed creates a psychological blind spot. Because the response is instantaneous, the software feels weightless, as if it exists entirely in the ether of the internet. In reality, generating that single sentence requires the activation of the most resource-intensive industrial supply chain humanity has ever built. This is the AI value chain, a 10-layer vertical stack. It begins at the interface on your screen and descends through deep software, specialized silicon, and raw industrial energy. Mapping this stack reveals why billions of dollars are flowing into cooling systems and power grids, even as the chat box itself remains free to use. Your prompt starts at layer 10, the end user. It passes through the layer 8 application interface and is processed by layer 7 development tools like Python or Hugging Face. At layer 6, the foundation model, the prompt shatters into mathematical notes. The AI executes probability calculations, predicting the next word. Built on layer 5, data, it digests trillions of words and images to learn patterns of human language. An AI is a colossal statistical mirror, reflecting the data it was trained on back to the user. Running these massive calculations requires immense computing power. Most AI companies don't build their own servers. Instead, they reach layer 4 and rent power from cloud providers like Microsoft Azure or AWS. Inside those rented servers are the actual engines of the boom. Layer 2, semiconductor chips, specifically GPUs. NVIDIA is the dominant designer here. They are the merchants of the industry, designing specialized chips like the H100 optimized for high-speed AI training. But designing a chip is not the same as building one. NVIDIA relies on layer 3, manufacturing. The physical fabrication of these components happens in a few hyper-advanced foundries, like the Samsung complex. The global supply of AI intelligence is physically limited by the production capacity of these few locations. Even the most advanced digital brain is tethered to the production schedule of a silicon factory. When a single GPU processes your prompt, it generates an immediate and undeniable physical result: intense radiating heat. Managing that thermal load requires layer 1, infrastructure. This involves the massive cooling systems and hyper-sterile environments inside data centers, preventing hardware failure. All of this cooling and computing depends on raw electricity. Training a single advanced model can consume as much power as thousands of homes. Artificial intelligence is ultimately limited not by software engineering, but by the physical capacity of the electrical grid. Following the path from the power lines back up to the chat box provides a complete map of the new economy. Investors view this stack in 3 buckets: infrastructure at the base, compute in the middle, and software at the top. Currently, the most consistent revenue is captured by the bottom layers. Companies building the physical framework see returns first. In this technological shift, the guaranteed winners are the ones selling the physical land, providing the raw power and the specialized tools. Looking toward 2030, the sheer volume of electricity required by these central models is straining existing power grids. This pressure is forcing a pivot toward edge AI, smaller, more efficient models designed to run locally on your devices rather than in a massive, energy-hungry data center. This brings us back to the moment your answer finally appears on your screen. When you hit enter, you pull the lever on the most energy-intensive physical supply chain in human history.
Thanks for watching. If you enjoyed this video, please like, share, and subscribe to Explainevo. See you in the next video.